in to get back to minus 1m minus 1. Hopefully you can see that that is minus 1.
Yeah.
Right, so now it's a better name for this. I know it's called grouping, but the better name for it is called double factoring because you end up factoring at least twice, usually twice. Do you see that both of these terms have an m minus 1 in them? Or I'm sorry, m plus 1 in them? That's
Yeah.
another GCF. So that m plus 1 comes out. That's why it's double factoring. And then you bring down the other stuff, the 2m minus the 1. Okay, now from here, we can solve for m by setting both of these equal to 0.
Okay.
All right, so then you can set m plus 1 equal to 0, 2m minus 1 equal to 0. And then you have to solve each of these. Could you solve these for us, please?
Uh, 1 and 1/2.
1/2 I agree with, but not the other one.
Uh, -1.
M equals -1. Good. Any questions on that?
Nah.
All right, so the next ones, the next grouping of problems, 16, say to solve using, well, they don't say, they say to graph to solve. So are you guys using a graphing calculator in the classroom?
Yeah.
Okay. Do you have a TI 8384?
Yeah.
Okay, so there's a couple of ways to do this. Way number one is to, again, set it equal to 0. That would look like this, x squared plus 6x minus 9. Is that what you guys are doing in the classroom?
Yeah.
Or option number two is you actually graph both of these and find the intersection.
Uh, now we do that one.
Which one?
The second one.
You're doing this one? All right, so you have your calculator out?
Yeah.
Okay, I'm going to get mine out and I'm going to share that screen and we're going to talk about, um, let me give me just a moment to get that up. Didn't know I was going to need a calculator for a lesson today, so just a moment here. Okay, so I've got a TI 83. Let me share that screen. And it's going to look similar to yours. I don't know what you have, but it's probably not going to be exactly the same. All right, so go to y equals, and you want to type in x squared plus 6x, and then 9. Let me know when you've got that in the calculator.
Yeah. Okay.
Yeah. Okay. Now, when you hit the graph button, I don't know what's going to appear on yours, but you might see this right here. And if you don't see this, let me know. I can show you how to get there. It's under Zoom.
Okay.
You have something that looks like this, roughly?
Yeah.
All right. So now to find the intersection, you have to hit second and then calc, which is above trace. which is, it's basically second trace, but it's the calc. And then
Uh,
we'll do the intersect. Let me know when you've got that up where it says first curve. Have you seen this before in class using the second calc intersect?
yeah,
All right. So it says first curve. So you just have to get near the intersection point. Like believe it or not, where my cursor is close enough. Like what you don't need to do is get right there on it. You can if you want, but just nearby. And then you hit enter. And then it should jump you to the second curve. And see how you're already pretty close to the intersection point there? You just have to get close. All right. You don't have to be on it, just close. Hit enter again, and then it'll say guess, and you just hit enter again. So you should get something like this for your intersection points. I'm going to grab a snip of this, put into the other window. Uh, do you have something like that on your screen?
yeah.
Okay, so it's x equals 1.25. Now the other ones are going to be a little bit harder to do because of like where all the words are. So you can always do this. You can always change your window. So I'm going to ask you to do that here. I'm going to change the window Y max to 20. What that'll do is it'll give us a little more room on this. Do you have that done? Go back
Uh,
and then that's under window here, Y max to 20. And then we want to graph it again.
okay.
So your graph will look, you'll have a little more room here on the graph is the whole point.
All right.
So now we're going to do a second calc intersect again, number 5. Okay, and this time we want to get closer to that one on the left there. So you have to hit the D. You can't see me clicking, maybe you can hear it. We want to get close to the intersection there.
All right.
Is that okay?
Yeah.
You hit enter, then it should jump you to the second curve. Like you shouldn't have to do anything, but and what a lot of students can you just hit enter, you just get right there, enter, guess, enter, and then you should be able to get the other intersection point there.
Okay.
And I hope you're following along. Like I already know how to do this, so I hope you're trying to do this along with me so that you can also, be able to do this on your own
Yeah.
without my help. Okay, so I'm going to jump back to the other screen for a moment here. So what I did here is I grabbed 2 snips of each of those intersection points. It says to round to the nearest hundredth. That's 2 decimal places in both cases. And there's your answer. Any questions on that? Thoughts on that?
Yeah. No.
Okay, so to do number 18, it's really, really similar. Really, really similar here. The graph will look different, but it's the same process. Okay. So this time, y1 is minus 1/5 x squared plus 740. And y2 is 3x, like that. So we're going to go back to the calculator and we're going to graph these. So when you go back to y equals, click on y equals.
Okay.
It's the graph to do a fraction and or to do a negative, to hit the negative button. 1 divided by 5 x squared plus 740. And then 3x there. And
Okay.
Okay, now when you graph it, if you have the same window, let me know when you've got this on your screen. You've got this entered. I don't want to rush you here.
All right. I'm there.
You're there. Okay. So graph it and you'll see something maybe like this, depending on what you're doing. Um, but you don't see the whole thing. You'll say, well, I just see the line. The line is the y2. You're like, where's the other stuff? So to find the other stuff, you can go to zoom, hit the zoom button. And if you go all the way down to 0, zoom fit, what it tries to do is it tries to determine like the window that it should be in. So hit enter on zoom fit
Okay.
and it should refresh the graph.
Yeah.
Now this isn't any better, unfortunately. Like this doesn't really help, but it tries to help. Okay. So this is where we've kind of got to go back to like what do we think the graph looks like? So I'm going to go back to the other screen here for a moment. Do you remember what the graph of a minus 1/5 x squared looks like? Roughly, could you
Uh,
describe that?
was it a parabola?
It is. And it starts at 740. It kind of comes down like this, and then the 3x goes up like that, and then this goes down that way. So we need a pretty big window to like figure this out. So this is the challenge. The challenge is like it's like how what kind of window will work?
Yeah.
And it's like, well, I don't know. It's a pretty big window. Um, so we're gonna so we when you're in your calculator, it's not very intuitive. It's not like our phones where we can just kind of touch screen them, and you got to kind of figure this out. So we're gonna go up to 1,000 on the Y and down 1,000 on the Y, and then let's go over I don't know, maybe on the X, let's go like 200 and minus 200. Okay. So to do that, we're going to go back to the calculator. That's a little bit wonky going back and forth here, but that's what we got to do today. You're going to click on window and we're going to change some of these other numbers. So the X min, I suggested minus 200, X max 200. Now the X scale, that's the tick marks. Usually like 10% of those numbers is good. So maybe like 20 or 40 for your increments. And then Y min, we're going to go minus 1,000. And this is just a guess. Like, I don't know if this is right. I don't know if it will work. We're just trying something. We're taking a step in the right direction. Let me know when you get all those numbers put in. Make sure you use the negatives in front of the X min and the Y min. If you don't have the negatives, it won't quite look right. Or get
Okay.
a syntax error.
All right.
Whenever you're ready, we can now graph.
Yeah, I'm ready.
Okay, so click on the graph. Okay, there's the parabola. And look at that. We got lucky here. We kind of picked a good window where we can find the intersection points. Okay. So to find the intersection, again, you hit second calc, which is under trace, second calc, intersect 5. And I want you to find the right intersection point for me, please. And if you have some questions, I'm happy to answer them here.
The right intersection point.
Yes, we just did this in the previous problem. So your first curve, you're gonna hit enter, second curve, you're gonna hit enter. It's gonna ask you to guess, you hit enter again, and it'll give you that place right there.
Is it is it 740?
We're looking for the X value. The X value.
Uh,
It's not 740.
0?
Are you following the steps I'm asking you to do, which is hit second calc, intersect, hit enter on first curve, enter on second curve, and so on?
Yeah.
Okay, well then we'll give you the right result. Like I don't think you're doing what I'm asking you to do, because if you did, you'd be giving me a number around, I don't know, 50. It'd have a decimal probably. It's not 0.
37.
You have to do the second calc intersect. It's the only way to do
Oh,
this.
well, I got 47.
Okay, that's better. That sounds better to me. Enter, enter, enter. All right. Now, I think you're just tracing along the curve and you're not hitting second calc intersect. Because if you did second calc intersect, we should get the exact same answer. 100%.
Okay.
All right, so do you have questions? Because I'm gonna ask you to find the other intersection point.
No.
Okay, so to do the other intersection points, the same thing. Second calc intersect, which is 5. You down there, you can either hit 5 or go down to 5 and hit enter. It says first curve, so you trace close nearby near this first intersection point. Just get nearby. You don't have to be on it. You know, if you're really close, just nearby.
At 5.
Yeah. It's giving me an error.
Okay.
He's getting an error.
Okay. Well, he's not telling me that, and
Right,
I have
right.
no way
I
to see
know.
his screen.
He's
So
still
the
getting
reason
over the crud.
probably he's getting an error because either this is not, and I don't. That's why I asked him numerous times if he was having issues because I can't see his screen. But I could say, does your screen look like this? And he said yes. And if this, like where my cursor is hovering, isn't a negative, which is the one here under the 3, he will get an error. If he goes to window, we change the window here to minus 200 and 220. If these aren't the same, and I did ask him, like, you got to tell me, hey, I don't understand. I can't see what he's doing. I can only see, does your screen look like this?
Uh, when I'm going to calc it, it keeps giving me an error for when I try to change the intersect.
Okay, like we got to try this one at a time. Like it's like we got to restart, and that's okay. Go to y equals. Does yours look just like my screen?
No. Hold up. What the-
Okay, you gotta make it look like mine.
Not
You gotta clear
clearing.
those out.
think it, yeah, it is now.
It's gotta look exactly right like it. So if that's the case, click on window next.
Yeah. Okay.
It's still
And
different, or does it?
Now it's gotta change the numbers.
is this the same? You said this
Yeah,
is the
that's the
same,
same.
right? Okay.
I don't know
Okay,
if
so
it's wrong.
go to window
Um,
and enter these numbers.
Yeah.
Okay, now when you hit graph, you should see something like this once it finishes graphing.
Yeah.
And if you don't see this is where you say, hey, Matthew, like mine isn't the same. I got an error. I have to know that there's a difference. Otherwise, I assume that there is the same. So does
It's
your
right
graph?
this time. It's
Excellent.
right.
Yes. Yes. Excellent. Okay. This is where you go to second, you hit the second button and then calc, which is under trace, second calc, intersect number 5. You go down and choose number 5. Hit enter. And your cursor might be in a different place than mine, but
Yeah.
what I want you to do is trace, use the D-pad here on the right and trace over to that one on the right. First curve. So it's saying what the calculator is trying to tell you is like pick a place on the first curve that's nearby the intersection. We're nearby. So get somewhere kind of where mine is. Doesn't have to be exactly, but and then hit enter when you've gotten to that place.
Okay. What I do now?
Did you hit enter?
Yeah.
Okay, it should say second curve now. Do you see that?
Yeah.
And then it actually jumped to the second curve, and it's actually pretty close to the intersection point. So you can actually just hit enter. Then do you see the word guess?
Uh-huh.
You can guess right there, hit enter again. Do you get this point? 53.788.
Yeah.
Excellent. That's what I wanted to hear. Now, we're going to repeat the same thing for the other intersection point. Second calc again, second calc. Go down to intersect, which is number 5. Now you trace with the D-pad there, directional pad, you get to where you're nearby. And believe it or not, where my cursor is nearby. Like you don't have to get right on top of it. That's the mistake.
Uh, and what now?
Hit enter for the first curve.
Mm,
And then do you see where it says second curve?
yeah.
Hit enter again. And then yes, hit enter again. And you should see this point right here.
Okay.
And I'm going to snip that into the other screen so you've got them there. Okay, any questions on what we just did before we move on to something else?
No.
Okay. Right. That is everything from this page according to what Mom sent over. And we'll go to wait a second. Okay, then page 23, circle problem. Yeah. So now we're moving on to the other page where there's some circled problems there.
So that's in your book.
Yeah, so page 23, we want to get that out.
And then
We'll look at number 1.
I need that. You don't need this. This is your homework.
Uh,
Yeah. Well, the other part of your homework.
All right, so here's number 1. Let me know when you can see that. Got that out in front of you.
all right.
So this is saying g of x equals the absolute value of 4x, but there's a little bit more here. It's really first take 4 and multiply it by x, then take the absolute value of it. So you're going to first multiply by 4, and then second you're going to do the absolute value. Okay. So we're going to start with this first x value. We're going to find g of -4. That's the absolute value of 4 times -4. like that. So let me know when you get that written down on your page. Then we'll talk about how to evaluate it. Because the order in which you do things does matter here.
Okay. That,
Is that okay so far?
yeah.
All right, so we're first going to multiply 4 times -4, which is -16, and then take the absolute value of it. Do you remember what the absolute value of, do you remember what absolute value does for a negative number?
Yeah.
Okay, what is the result then?
16.
16, good. Now, the way the instructions are written, it says, find the set of ordered pairs for each functional rule when. So the result here is -4, 16. Like you have to write this ordered pair as your answer.
Okay.
So we're going to do the same thing for the next ordered pair. G of -1/2 equals absolute value 4 times -1/2. So you first are going to multiply these two together, then take the absolute value. So what is
Uh,
what is half of 4?
2.
Okay, so then it's that negative because with it. So what's the absolute value of -2?
2.
It's 2. So this ordered pair becomes -1/2 because the x value comes first, and then the output y.
No.
All right, any questions on that?
Nope.
Okay, so see if you can do the next one here, g of 0. I'll be right back with you in 30 seconds to see how you're doing on this one, but take a look at that, please.
All right.
All right, how are you doing on this one?
Uh, got 1/3.
Okay, tell me how you did that. How did you get 1/3 from 0?
Uh, I put y equals uh, or yeah. Well, I put y equals 3x plus 1.
Where's 3x plus 1 coming from?
Are we
We're
doing
we're
it?
doing we're doing absolute value for x.
Oh, bruh. I'm on the wrong one. Never mind.
Okay, all of these are for number 1 here for x. So
Dang. All right.
give that another try, please. You have an answer for me?
Uh, 0.
Absolute value of 4 times 0 is 0. So the ordered pair is 0, comma 0. All right, next one is 3/4. This is the absolute value of 4 times 3 over 4. Now, when you have a fraction and a whole number, you treat the whole number as a fraction by putting it over 1, 4 over 1, like this. And then you multiply the tops and multiply the bottoms. 4 times 3 is 12. 1 times 4 is 4. 12 over 4 is 3. The absolute value of 3 is 3. So this produces the ordered pair 3/4, comma 3.
Okay.
What I'd like you to do is the next one here, g of 2. That's the last one.
Is it 2 and 8?
Okay, on to number 7. Number 7 here. All right, so let me grab the instructions first. Always good to know what we're doing before we do it. All right, so number 7 is the absolute value of f of x is the absolute value of x. This is a parent function, and it's one that you are supposed to know, meaning like you're supposed to have some idea what it looks like without, without me graphing it first. This looks like a V. And so if you don't recall here, I'll graph it for you. It starts at 0 and goes up and to the right, up and to the left like that. It looks like a V. It's got a V shape to it.
Okay.
All right, so we're asked to find the domain and range. So let's take a look at this. Domain are the X values. It's like, is there any restrictions? Is there anything that this can't be? Anything that you see that looks odd? And this has no restrictions. Its domain is minus infinity to infinity.
Um,
Does this look unfamiliar to you? Like you didn't see this in class?
I mean, I think I has. I don't think I was present during the teaching of it.
So domain you can think of as left to right. You can ask yourself, well, how far left does this go? Well, it goes left forever. How far right does it go?
Okay.
It goes right forever. now the range. So the domain is the X values, the range is the Y values. You can think of the range as the min to the max, or like the bottom to the top. So it's the Y values though. What is the smallest Y value where my cursor is?
Uh,
What's the Y
0.
value there? 0. So we know it starts at 0. And then how far up does this go? Like how far up in each direction does it go, or are they the same?
Well, I would think they're the same.
How
Infinite.
far up does it go? Yeah, infinity. Infinity. Now infinity always goes with a parenthesis. Positive infinity, negative infinity, they always get parentheses. The number though could go with a parenthesis or a bracket. The reason it's a bracket here is because 0 is included. Like it can actually be 0. Now to answer the last part, if you look at the instructions, the last part says, is it continuous or discontinuous? So the simple answer for continuous or discontinuous is if you can draw it without lifting up your pencil. So notice how you can draw it goes down, it goes up. You can draw it without lifting up your pencil. Yes, it's continuous.
Okay.
So we'll come back to 11, but let's look at the grouping of 13 through 18 next. Let me know when you get all this down for number 11.
Okay.
Any questions on that? Take your silence as a no. And here he goes.
We're back. Our
All right,
internet
no
blinked.
problem. No problem here. All right, Tristan, so I got 2 more problems up on the screen. Are you able to see those now?
Yeah.
Okay, so let's look at 14 on the right first. So if I draw it, if I just put my cursor here at the lower left and I start drawing it, see how I can draw it without ever lifting up my pencil?
Yeah.
That means it's continuous. But I think you can see on the left here that this one is not continuous. There's going to be a problem. Like if I try to draw it here from the left, I get to this point right here, and then what do I have to do? I have to lift up my pencil to draw it and keep going. And so this right here, this is called a jump. Is that something you've heard before? A jump?
No, but I mean it makes sense.
This one is not continuous.
Okay.
So I want you to look at the next two. I'm gonna grab them snip them in the screen here, but I want you to tell me if either 15 or 16 are continuous or not continuous. Get up on the screen here. So what do you think here? 15, 16.
Does that like circle signify anything?
Yes. Good question. It means there's a break.
Well,
So
would that make it not continuous then?
exactly. Yes. Good eye on that.
Then 16 is obviously not continuous.
And you do the next two.
Yeah.
They're both not continuous. Good. Okay. That's a big thing. Like you're gonna get some questions on your test about that. Now, are you in a pre-calculus class this year?
Yeah.
Okay. All right. Well, got some challenging stuff ahead of you. Okay.
Oh yeah.
All right. Any questions from what we did today or any thoughts?
No.
I'll be able to
Right.
help you. I've got the teacher's edition to the book, so.
Excellent. Yeah, I mean, there's a few that we didn't get to today that we, really, require a bit more explanation. 25 is calculus question. That's why I was asking what class you're in because I don't quite know why that's here, but yeah, I don't write the books. So all right, we are going to stop